First, let's create our createOffer endpoint. Let's create a public endpoint that allows us to create offers. We can use the endpoint attribute and give it a name, createOffer. And the function name will be create_offer. The endpoint will return the offer ID to the newly created offer. This method will require the following parameters. Accepted token, the token desired. It would be the type of token identifier. Accepted nonce, which is in U64. Then an accepted amount, which in case of the NFT is 1 or greater than 1 in case of SFTs, meta ESDTs or fungible tokens. This would be of type big unit, a managed type that allows us to work with big numbers. The final parameter would be the accepted token address, which is a managed address. For implementation, we'll need a payment. In return for something provided by the offer's creator, the accepted payment is received. We will define a new variable called payment and use the call value single ESDT. In order to be able to receive this payment, we'll need to also make this endpoint payable using the payable keyword. We will need to specify what kind of payments do we accept. We can have either EGLD. We can only accept EGLD on this endpoint, or we can use the asterisk to specify that we can accept any payments, EGLD or ESTDs. Next, we'll need to see who's the caller. We can use the getCaller function. It returns the manage address, which lets us know who the caller of the endpoint is. We also need to see what's the last offer ID available and incremented by 1. So the new offer ID would be self.lastofferid.get. Using the command, we can read from the storage mapper, and we would add +1 to this. We should now be able to create the offer. The offer accepts as a creator, which in our case is the caller. An offered payment, which in our case is the payment that we previously get from the call value. We will need an accepted payment and an accepted address. We have the accepted address already, so we only need the accepted payment. We can also return the new offer ID. we need to save this offer. We can use the offer's storage mapper. Let's also save the new last offer ID. We can also simplify the existing code. As you can see here, the last offer ID mapper is initialized twice. We can have a new mapper variable where we store storage mapper, and we can use it to simply read and write data inside the storage mapper. Now our getNewOfferID initializes a single variable, reads from the storage, adds a +1, saves the new offer ID in the storage of the contract, and then returns it. So now we can use this function to read the new offer ID. Let's rebuild the contract using the scmeta or build command. Nice, it works and builds correctly.